There are three major topics in calculus: limits, derivatives, and integrals. Today, we're going to talk about the derivative. So the derivative of a function is the limit as h approaches 0, f of x plus h minus f of x all over h. If I ever talk to you about the definition of a derivative, it's the limit as h approaches 0, f of x plus h minus f of x all over h. Now I'm hoping you instantly recognize that as the slope of the tangent line. So anytime we're talking about derivatives, we are calculating the slope of the tangent line. Now slope is change in y over change in x, so a derivative is also a rate of change, simply because slope is change in y over change in x, so we're talking about change. Now the notation. You'll see all kinds of different notation depending on what book you're using, what school you go to. The ones we tend to use the most in our class are y prime, f prime, and dy dx. And you might be saying, why are there so many? So when calculus was first coming about, they were using calculus in England and Germany, and so different countries use different notation, and because they were doing different applications. So why will we have three? Just for the different applications. So these are the ones you want to be most familiar with. But if you're ever doing calculus from a book and you see this sort of notation, they're just saying, please find the derivative. Way you pronounce it, y prime, f prime x, dy dx. All right, so how do we find a derivative? Determine the derivative. We start by using the definition, which is the limit as h approaches 0, f of x plus h minus f of x all over h. What is f of x? The original function. What is f of x plus h? You remember what we said. Anywhere there's an x, give yourself a bracket. And whatever you're finding f of goes in the bracket. So we're finding f of x plus h. So we put x plus h in all those brackets. So f of x plus h becomes x plus h squared plus 2x plus h plus 3. So we're putting this in place of f of x plus h and putting this in place of f of x. My color coding's a little bit off, but this is the red one. All right, let's expand that. X squared plus 2xh plus h squared, 2x plus 2h plus 3, and then we're subtracting all of those. Okay, now remember we said a great way of checking our work. Everything we put in for f of x is going to get canceled with something here. So the x squared goes, the 2x goes, and the 3. So because everything that we put in for f of x is eliminated, we're feeling pretty confident here. We'll be left with 2xh plus h squared plus 2h all over h. Looks like we have a common factor of h that we can get rid of. So we have the limit as h approaches 0, 2x plus h plus 2. And as h goes to 0, we get 2x plus 2. Oh, what's this? So when we were finding slope of tangent, we wrote down m. We're finding derivative, we write down y prime. So is there anything different here between finding the derivative and finding the slope of the tangent? No. No, it's doing the exact same thing. We're just using new notation. So at the point 1, put in 1, you'd get 4 for the slope. And so m for slope, y prime for slope, they mean the same thing. So essentially, finding the derivative, you're finding the slope of the tangent, you're doing exactly what we did in the previous lesson. So your job is to finish the previous lesson. Let's get 6 to 10 done today.